Our game with PYTH currently has input from the sliders, and we can move the character around by continually pressing one of the buttons. The game also has bounds control, so it will hit the boundary and it will be detected. What it doesn't do is what you would expect. You just press the button once and the character continues to move in that direction until another button is pressed. In order to implement this with PYTH, we're going to need to use the async functions of Python. This is our objective. You press it once, the character continues on the current path until it reaches the end of it. Once it reaches the end, it stops. You could also adjust the speed here. So if we force the character to go up, it's going to stop, and down it'll go up. You can also go this direction. However, in order for these things to be working all at the same time, you have to use async IO. We're going to cover that. You are in a beginner course that if you decide to pursue computer science in college, you will be prepped for more. We're going to talk about asynchronous versus synchronous communication. The current behavior of our game prior to starting the tutorial is that you press the button once, the character moves once, you click it again, the character moves again. Each action must start and finish before the next one starts. This behavior will work in something like Pygame, but because of the architecture of PYTH, which is using a network communication, it will freeze the UI. So synchronous behavior is, if you use a car analogy, there's a single road, one car at a time, and you must wait for the car ahead to finish. So you just go at one after the other. Our fundamental structure is more complicated, but this is no problem since our objective is to learn. We'll have the opportunity to learn the real basics of asynchronous. Multiple things are happening at the same time, and this is actually what we want. We want to get into asynchronous communication. So you have a simple way to learn at a high level like what this means. You hold the button, the character moves continuously. The UI stays responsive. The UI is not locked when the character moves. The background work happens as the UI updates. This is like a multi-lane highway. We're going to cover a concept called threading, which is basically these two lines. So before you think, oh man, threading is difficult, we're just going to walk you through it. There's no deep dive on it. It's basically these two commands, and then there's this command here for the queue. So don't worry about it. But we'll cover the concept here. So a thread is like a separate worker. So the main program handles the UI, and the background thread handles the game logic. And they work together simultaneously. So you basically have two workers that are working at the same time. Like one maybe is the restaurant manager, handles the customers, and there's a separate person that is like a thread that is handling the background process, maybe cooking the food. If we don't do this, at least in the architecture that we have, the UI will freeze. And so you can't, while the character is moving, you won't be able to access the UI. And it's a bad user experience. So although it sounds rather complex, the solution is just a couple lines of code. But there are these concepts that we are trying to just give you a brief introduction to.